Hello, James Flaten here with the Minnesota Space Grant with a high-power rocketry instructional video talking about grinding motors, grinding the motor delay so that the motor eject goes off, hopefully at apogee, and also sizing ejection charges, which is an important thing to be able to do even if you're using motor eject. So first, let me share my screen, including sharing sound, and watch a quick video. So here in the center of the screen is a Goblin rocket. And this is a single deploy rocket that's going to have an H-195 motor, and it has been ground down so that the motor eject will go off, hopefully at apogee. Let's watch.
H-195, projected altitude 1,330 feet. Going in 5, 4, 3, 2, 1.
Okay, burning, and now it's coasting.
Lovely little whistle.
Now I'm going to zoom in a little bit. Apogee, explosion, parachute.
And to shoot. Good.
So that's how it's supposed to work. Basically, that coasted for about 8 seconds. But the motor is called an H-195-14A motor. The dash 14 means it has 14 seconds worth of delay grain, and A means it's adjustable. So the students who built that rocket wanted to adjust their delay, so it only went off, it went off after 8 seconds, not 14 seconds, which means they removed about 6 seconds worth of thickness in the delay grain, so it would go off earlier. So there's two things you need to do. One is you need to grind down your delay grain to the appropriate time. And the second thing is you need to have the appropriate amount of ejection charge, powder, to make sure that you break open your rocket and get out your parachute without breaking anything that you don't want to break. So hence grinding, motor ejects, and also sizing ejection charges. Let's talk a little bit about grinding motors first. So first of all, you, number one, need to know what kind of motor you're dealing with, and then you need to have the right tools. And if you don't have the right tools, but you're at a launch site, presumably somebody at the launch site has the tools and can either lend them to you or help you do them. So let me just show you some motors here. First of all, if you have Cicerone motors, here's a 54 millimeter motor. Here's a 38 millimeter motor. They're both spent motors, but they're in their cases. And so in the case of, well, all motors, I guess, the ejection charge is at the very top, and underneath it is some thickness of delay grain, and then below that is propellant. And so the way Cicerone builds their motors is the ejection charge is built in, and so to access the delay grain, you need to take the motor apart and access it from below using a tool, a grinding tool, a drilling tool, basically. So let me show you a couple. Here's a grinding tool for a 54 millimeter motor. And basically, if I look inside there, I can see that there's just a drill bit, frankly, and I can retract it or extend it as I'm rotating this piece on the back. And the piece on the back has numbers on it, and so as I rotate it, it basically tells me, okay, that's going to grind off. Let's see, that would be 5 seconds, 6 seconds, 7 seconds. This is a continuous rotator, and so this is the nicest one of all, frankly. It allows me to not only do individual seconds, like 3 seconds or 4 seconds or 5 seconds, but I can even turn it so that I'm in between, so 3.5 seconds if I really want to. And then once I've chosen the depth, then I lock it in place, and that means that the drill bit is going to stick out a certain amount, and then I will open up my motor so I can see the delay grain, and I will touch it against the delay grain and grind away until the bit is not biting any more delay grain. I'm not going to do that part, and the reason is I don't want to do that until I'm on the verge of launching a rocket, which I'm not right now. So here's the tool, and you really can't do this process without this tool. That's the tool for the 54 millimeter. On the other hand, here's the tool for Cicerone. for the 38 millimeter motors. And so this particular tool has notches in it for taking away 7 seconds, taking away 5 seconds, taking away 3 seconds. And in each case, same thing. There's a drill bit and it sticks out more or less. And you'll notice that the numbers are every 2 seconds. On the other hand, it's sold with a washer. Don't lose that washer. That's very important. And the reason is the washer is supposedly the thickness of 1 second worth of delay grain. So if I set this on 7 seconds and I put the washer on, now I can't get quite as close to the motor as I could before. And so that's considered 6 seconds. Take the washer off. I can go down to 5 seconds, put the washer back on, and now I'm at 4 seconds, etc. So using the washer, you can get 1 second intervals. So 5 or 4 or 3. That was Cicerone. Aerotech. Aerotech is completely different. An Aerotech motor, and I happen to have 2 spent disposable motor systems. So this is a 38 millimeter DMS Aerotech motor. Here is, in fact, an H195 29 millimeter Aerotech DMS motor. DMS in this case means disposable motor system. So these motors don't need a metal case. And then Aerotech also sells motors that do need metal cases. But in this particular case, Aerotech has a different approach to grinding the motor. At the top of each of these motors, you see the same feature, and that's this yellow thing sticking out. And then there's basically a tube. And so the idea is the tube is where the ejection charge will go, but it's not installed when you buy the motor. They sell you the ejection charge separately, as opposed to Cicerone, where they install it. And since it's not installed in the Aerotech motors, you can actually reach the delay grain from the top. You just need the right tool. And there it is. There's the tool. And in this particular case, the drill bit sticks out a long way. And the reason this drill bit sticks out so far is because you have to reach in quite far before you can possibly reach the delay grain way down here. You're reaching through where there's eventually going to be a motor eject, an ejection charge. Okay? And so this particular tool, same tool is used to grind both of these diameters. So motors, they call it their universal tool. And it has the takeoff 4 seconds side. And so in the case of takeoff 4 seconds, there's this lip down here, or there's a lip and then there's this depth. And so you can reach that far into the motor. And then if I take the entire thing around and turn it over, now it's called takeoff 8 seconds. And so in this particular case, this is deeper, which means that I can reach deeper in, take off more delay grain. On the other hand, 4 seconds and 8 seconds, that's pretty coarse. So this also comes with a washer. Don't lose the washer. And so the washer, in this case, goes way up here. And so when I was on the 8 seconds, now that I have the washer in, the washer is a thickness of 2 seconds worth. So now I'm down to not poking in so deeply. And so this is 6 seconds. So it's 8 seconds without the washer, 6 seconds with the washer, turn it around, take off 4 seconds without the washer, or put the washer back on and take off even less than 4 seconds. Take off 2 seconds. So I have 2 or 4 or 6 or 8. So every 2 seconds, as opposed to this Cicerone device, which was able to do every 1 second with a washer. And this one was continuous. It could do even fractional ones. But you only use one tool. You use the tool that goes with the motor. And so basically some of these tools are coarser and some of these tools are finer in resolution. On the other hand, even being able to grind things within a second or even within 2 seconds typically is adequate for high power rocketry. Now the question is, how big should the ejection charge be? And in the case of Cicerone motors, they choose it for you. So if you have a 54 millimeter motor, it comes with a built-in 2-gram charge, 2.0 grams. And this one has already been spent. And so it was at this location and there was paper over the top of it and that has exploded already. This is a spent motor. 38 millimeter diameter motors like this one come with 1.3 grams. So in other words, the company believes, and this is actually usually true, this is likely to be used in a motor, in a rocket, that 1.3 grams would be adequate. Sometimes that's even more than you need. And again, it's blown out already. Aerotech does it differently. Aerotech sells you a motor that doesn't have an ejection charge at all. But then they sell you an ejection charge. They sell you a little vial, or well, it comes with the motor, there's a vial. And this particular vial has, I'm looking at it, it's a graduated vial, approximately 1.5 grams or so of powder in it. So the idea is you can pour the powder in as much as you want. In fact, often we just pour all of it in, and then you cap this. And so now I have built in a motor eject. Don't forget to put in your powder. Okay. 1.5 grams, for instance. And so here's the smaller one, same deal. Pour in the powder that comes with the motor. On the other hand, it's a good idea to know whether or not 1.3 grams or 2.0 grams or 1.5 grams, is that an appropriate amount? So let's talk a little bit about how to calculate the amount of ejection charge powder you want using a simple calculator. So I'm going to share my screen again, and I'm going to pull up what I call my simple ejection charge calculator. So this particular ejection charge calculator, there's two things to consider. One is, what is the volume that you're trying to pressurize? And typically we pressurize it to the same amount, maybe about 15 psi or something like that. And then do you have to actually break anything, like break shear pins, or not when you are making this part of the rocket break open? So in this particular simple ejection charge calculator, the blue cells are the ones where you put in your numbers, and I made them green. The green cells are the answer. Okay, so right now it says if you have a 2.6-inch diameter rocket and you need to pressurize 14 inches worth of it, it looks like you need about 0.58 grams of ejection charge. Truth be told, I never use less than 1 gram. So if the calculator says half a gram or less than 1 gram, I'll just give them 1 gram anyway. It's almost always good to be, it's definitely good to be too much than too little. If it's too little, you don't get your parachutes out, and that can be a very bad day. So let's take a quick look at, here's Open Rocket. So here's a rocket. This rocket is intended to fly as a single deploy rocket with a payload bay. And so this particular rocket is made of 3-inch diameter blue tube, and it has a bulkhead right here at about 25 inches on the scale up there. And so the portions of the rocket above the bulkhead are never going to get pressurized. That's the payload area. Maybe they'll put a payload in, maybe they won't. And then the idea is the area below this bulkhead at 25 inches. This is to be pressurized, and then there's the motorway down there. And basically this entire tube is capped off by a centering ring right here at about 45.5 inches. So it turns out from about 25 inches up to 45.5 inches or so, that's what is to be pressurized. Let's find out what is an appropriate amount of powder, black powder, gunpowder, to put into this area. So I will go back to my simple ejection charge, and I will say 3, because it's a 3-inch diameter rocket. And what was it again? It was from 25 up to 45.5, so 20.5 inches. 20.5 inches. 20.5 inches. And it immediately tells me that I need about 1.1 or 1.12 grams of black powder. That's fine. If the motor has 1.3 or 1.5 grams available, that would be fine. I would probably just leave it alone. But frankly, I could perhaps get away with about 1.1. In fact, if you ever put 2 ejection charges in a certain part of the rocket, one of them is to serve as a backup to the other. What I usually do is have the first one, the primary one, what the calculator tells me to use, and then the second one, the backup one, always has to be bigger. Frankly, if 1.1 grams didn't work, I'm not going to do it twice. I needed to use something even bigger. So a 1.3 gram motor eject, Cicerone, or a 1.5 gram Aerotech motor eject would be a good backup to a 1.1 gram if I had electronics on board to fire the charge and apogee and let the motor go off a little bit later. I'll make a second video that talks a little bit more about actually building ejection charges and installing them yourselves. On the other hand, here's one thing that the ejection charge calculator will help me do, and that is figure out how much more powder I need if I have shear pins. So down here is another blue box. I'll put a 0 in it for the moment. And this is if you're using 256, let me change that to say 2-56. size 2, and then 56 threads per inch. They're just called 256 shear pins now on screws, machine screws. And you always should use 2 or more. And the reason is if you only use 1, sometimes it will break asymmetrically and it will fail to open up. So I'm going to say 2. And notice as soon as I put the 2 in and hit return, it changes the amount of powder I need up to 1.86 grams. Remember, it was 1.12 grams. And so apparently to break those 2 shear pins takes the majority of another gram. If I had 3 shear pins, now I am at 2.23 grams. So in other words, if you are to break shear pins, you will need extra charge, and it's good to know that. Generally speaking, on a single deploy rocket, you will not break shear pins. You'll just have a good friction fit. And so that's what was the case in that video we saw. That was a friction fit. There were no shear pins there. And that's sort of the getting your motor eject to go off is very reliable, and getting your friction fit to open up is very reliable. In fact, if you don't have your friction fit tight enough, sometimes it can open up before you want it to. But it's possible, especially if you have pins in there and you have insufficient charge, or if you don't have a tight seal, so you can't hold the pressure long enough for things to actually move on you, then the pressurization can escape, and things won't break, and then you might fail to get, in this case, perhaps a main parachute. So, last thing, when you're trying to do prepping your motor, for instance, make sure that you've ground the delay grain so that it matches what OpenRocket is telling you. Let me go back to OpenRocket here and show you where to look. So here's OpenRocket, and here I am on the screen that shows me some simulation values, and it tells me how fast it comes off of, in this case, a 96-inch rod. I want that to be more than 45 feet per second. How high this is likely to go. The fact that I'm at apogee and I deployed at apogee, so I'm not really moving very much at all. Optimum delay, this is it, optimum delay. Okay, that's interesting. Basically, I guess that when I click there, it will sort it by optimum delay. I don't want it to be sorted by optimum delay. I want it to be in order in which I did the calculations, but here we go. So the optimum delay for this particular rocket, this is the coast time. This is how long the rocket takes to reach apogee after you finish burning the motor. This is the same thing that we want to put into our tool. So if the optimum delay is 8.85 seconds, maybe I'll round that to 9 seconds. Okay, so let's say if my optimum delay is in the vicinity of 9 seconds, but my motor was a 14A, 14 adjustable motor. That means I want to reduce 14 seconds that comes from the factory down to about 9 seconds. So I want to take off perhaps about 5 seconds. And that means I need to set my tool so I can take away 5 seconds if it is able to do individual seconds. If it can only do 2 or 4 or 6 or 8, I guess, then I just get to decide, well, do I want to go 4 instead of 5, or do I want to go 6 instead of 5? That's a discussion that you can have with your team and with your mentor. Okay, so enough for a video about grinding motors and sizing ejection charges. Next, I'm going to make a second video, and the second video will talk about actually making ejection charges and firing them on the ground. My recommendation is that if you have pins that need to be sheared, you really should try to shear them on the ground and make sure that the seal is tight enough and the amount of charge is adequate enough before you actually put the rocket into flight.